Yesterday, when we talked about adding and subtracting radicals, we compared the rules for those with those of fractions and variables, where we said, everything had to be alike. You only added the whole numbers, and the radicals did not change. Well, with multiplying and dividing radicals, it's the same thing as fractions and variables. In fractions, do you have to have a common denominator? Yes. No. To multiply and divide? No, you don't need it. Anything goes. Same thing with variables, same thing with radicals. But what we actually multiply are whole numbers with whole numbers and the radical stuff with the radical stuff. Okay? So if we were going to put this together through multiplication. Now when you're working with radicals, let me back up a step. Take a look at what's happening. What operation is taking place? Okay? We are multiplying here. We're not adding. If there was a plus sign, then we'd do a whole different thing. But now we're multiplying, and anything goes. So when we multiply...
You couldn't add those.
You couldn't add them anyway. Exactly. We are going to put together the whole numbers, and then whatever is under the radical. Now notice, when I put 4 times 9 together under the radical, I did not put 36 because I know that I would have to turn around and take 36 and break it back down. Okay? So I simply broke 4 down, and then I broke 9 down, and so I'm already at this point where I can simplify this radical. This is, under the radical, the square root of 2 squared times 3 squared. Well, what can I remove from here? A 2 and a 3. Well, what do I do with that 2 and that 3 that I'm removing? I multiply them with what was already outside the radical. So the final answer here is 36.
Is it always going to end up like that?
No, you may still have something left in it. Okay? But in this case, it just worked out perfect. So with multiplication, whole numbers multiply together, radicals multiply together, and you still have to simplify.
Is it all this easy, or does it get hard?
Oh, it gets harder. Oh my goodness. Okay. If you look at this expression, don't let it confuse you. Okay, look, today we're going to be putting together about 8 skills that we've learned. What did I just say about radicals times radicals? Put the whole numbers together, put the radicals together. All right, so outside the radicals, I have 2 times 4. I'll just write it out for you. And I have a times a, which is a squared, correct? The parentheses around it is simply to show that it's multiplication.
Like you multiply the a's separately or
The
something?
2 a's that I just put together are these right here. I just multiplied 2a times 4a.
So if it was 4a squared, would you multiply those 2?
Mm-hmm. Okay. Now under the radical, I've got 3 from here. I've got 6 from here. Notice I'm breaking it down and I'm trying to keep my 3's together. And then I have a couple of a's. I mean, this is really not too bad. Outside stuff together, inside stuff together, and we still need to break down or simplify what's under the radical. This is a square root, so I'm looking for pairs, correct? What can I remove? I have a pair of 3's that I can take out. What else can I take out? I have I have 1 pair, so I can take 1 more a out. Now let's just clean this up. On the outside of the radical, what does that give you? 24a cubed. Under the radical, what do you have left? A 2. And this would be your answer. Whole number times whole number, radical times radical, and then simplify. All right? No, I'm not ready for this yet.
It's a cube root. If one of them was a cube root and one of them was a square.
You cannot put those together. They have to be the same root. You'd have to leave them separate. Okay? You could put the whole number parts together, but the other part you'd have to leave separate. And they're not going to do that to you. Okay. This is multiplication, so they don't have to have the same radical. All we're going to do is combine whole number portions together and the radical stuff together. So with the whole numbers, let's actually multiply it out. It's 3a times what? Times 2a squared. All right, well, what is 3a times 2a squared? 6a cubed. Okay, so I've already got this outside the radical. Now, under the cubed root, let's try to keep our stuff grouped together. I've got 3 times, that's not the number I was looking for. Oh, well, 6. And I have how many a's total? Okay. Can I simplify the stuff under there anymore?
Yes.
I do have, because it's a cubed root, I have a group of 3 a's. So I can remove one more a. What about the numbers? No, I don't have enough of either one of them. So they've got to just be put back together. So under the radical, I've got the cubed root of 18. And then clean up what's outside. 6a to the 4th. Yes? No. This is just simply identifying which root I'm looking for the 18. This is the 4th root of a. It's not like 4 to the 3rd power. Okay? How's this?
Easy.
Okay. And what's the difference between this and the one right before? You're adding. This is a FOIL problem. We should be able to recognize that this is a binomial multiplied by a binomial. And so I'm going to apply FOIL. Okay? Well, when I apply FOIL, the first term times the first term, they are both under the radical, and it's 5 times 5. Now let's just keep going. Don't start simplifying yet. Outside terms multiplied together is positive times positive, which gives me positive. They are both under the radical, and it's 2 times 5. The inside terms multiplied together give me a negative 6 times 5. And the last terms multiplied together, under the radical, I have 6 times 2. Well, doesn't this look familiar? This is what we did last night. Simplifying the radicals and then identifying. Now we're looking at addition if we have any that are alike. Can I reduce this one?
Yes.
I have a pair of 5s. Take out a 5, there's nothing left underneath. What about the next one? No, so it's the square root of 10. What about the next one? No, so it's